All right, example 4. We've got a formula that's used. Oh, so here's the formula from the front side of the sheet that I told you guys weren't going to have to memorize. All right, they're going to be embedded in the problem if you need them. So h is our height, v is our initial velocity, which will have to be given to us somewhere in the problem. It looks like this. T is going to be time, h is going to be height in meters. All right, so we've got this rocket fired upward from the ground. It's got an initial velocity of 68.6 meters per second. So let's actually just plug that into our equation. So 68.6 times t minus 4.9 t squared. All right, so there's our initial velocity that they gave us, and we're plugging it into the formula that they gave us. It's fired upward. All right, during the rocket's descent, the parachute's deployed at an altitude of 196 meters. Find the time of parachute deployment. All right, again, if we rearrange this, it's a negative quadratic. All right, so it's opening down. Let's find the vertex of this thing, just to look. So negative b over 2a, let's see what that gives us. Negative 68.6 divided by negative 4.9 times 2, that gives us a vertex of 7. And let's just see what the k value is. Negative 4.9 times 7 squared plus 68.6 times 7. Okay, and that gives us 240.1. So the vertex is going to be somewhere around here, right? If we're looking at, if this is the k value of the vertex, but we're looking at this thing of an altitude of 196, that's lower than the vertex, which means if this is 240, 196 occurs around here. X-intercepts, we don't really care about those right now, but I can tell you that this thing probably does something like this. All right, so if we look at this, I realize that's a terrible graph, but if we look at this, 196 occurs somewhere during the ascent of the rocket and also occurs somewhere during the descent of the rocket. The question says during the rocket's descent, the parachute is actually deployed, right? So here's my parachute, which looks more like an ice cream cone, but you get the idea. We only care about the deployment here during the descent. So we only care about the height of 196. We'll get two answers. We don't care about this one. We only care about the one that's further out on the x-axis. This is height that the whole thing is set to. If we wanted x-intercepts, we'd set height equal to 0. We don't want the height at 0. We want the height at 196. So we got to set the whole equation equal to 196. Right, let's move it over and now set the whole thing equal to 0 to make it a true quadratic again. Plus 68.6t minus 196. I'm going to see if the whole thing is divisible by 4.9. I think it is. 68.6 divided by 4.9. Yes, the whole thing is divisible by 4.9. So we're going to divide the whole thing by negative 4.9 minus 14. T plus 40. That is awesome, because now we can actually factor that. I need two factors of 40 that are going to sum to 14. So I'm pretty sure that's going to be 10 and 4. So at time equals 4 seconds, the parachute is 196 meters off the ground. At time equals 10 seconds, the parachute is also 196 meters off the ground. Right? Again, it's during the rocket's descent, the parachute is deployed. So we only care about this one. So our answer is 10 seconds.